Okay guys, so in the past lecture we were seeing the preparation of aldehydes and we saw three methods for it. Okay, so in this lecture we'll also be seeing some more methods to prepare aldehydes. So let's get started. So the fourth method is we have Itard reaction. Okay, Itard reaction. So what does this says is, suppose we have a toluene, and on toluene we are reacting it with CrO2 Cl2 in presence of CrO3. Okay, and polar aprotic solvent CS2. So what we'll be getting is something like this as the intermediate. Okay, and this after hydrolyzing it in acidic medium, we'll be getting benzaldehyde. Okay, let us look at fifth method. We have, this is the commercial method of preparation of benzaldehyde. We have, in this method we have a toluene and we are using Cl2 HNO in the presence of sunlight, and we are getting CHCl2, and then we are passing water and we will be getting a CHO here. Okay, so sixth we have Gatterman co-synthesis. Okay, so here we have something like a benzene ring. Okay, on reaction with CO plus HCl, and we'll get benzaldehyde. Okay, so all these name reactions are there to be remembered by you. They are asked so many times in J level examinations or other uh, examinations. Okay, so now what we'll be seeing is preparation of aldehydes, in the mechanism involved behind various name reactions. So we'll just be seeing that. Okay, so before that, let me ask a quick question, belonging belonging to the previous concepts which we have already discussed. So suppose you have, so this is nowhere connected to the preparation of aldehydes, but just for revision sake we are doing this example. Okay, so what will happen if we have this compound as the reagent in presence of AlCl3? Obviously Friedel-Crafts alkylation would take place, but what would be the major product? So the major product would be something like this. If you answered or guessed it like this, you are completely wrong. The major product would be something like this. This structure is known as cumene. Okay, and why does this take place? I hope you remember that the intermediate would be a carbocation, something like this, which can undergo rearrangement. Okay, a single arrow only, which can undergo rearrangement to have more stable carbocation. Hence the benzene ring will actually attack on this carbocation. Okay, so let's discuss Rosenman reaction in depth. Coming back to the preparation of aldehydes part, so Rosenman's reduction. Okay, so what actually happened in Rosenman's reduction was, we are going to see just now. Suppose we have RCOCl, okay, and we are passing it in presence of H2 and PDBSO4. What actually will happen is this bond will actually cleave itself and it will have H and H on both sides of the bond. Hence reduction word comes from that. So we will have something like this and HCl. Okay, so next what can actually happen is, what will actually happen if we further pass this in acidic medium? Obviously we will have something like this compound. Okay, so second, let us look at Stephen's reaction, or rather Stephen's reduction. So we have something like RCN or nitrile, and in nitrile we are passing SnCl2 in presence of HCl, and we got converted into, first the reduction will take place, okay, for this triple bond or nitrile group, and then when we are passing H plus in acidic medium, H plus in water or acidic medium, we'll be getting RCHO. Okay, so this is pretty much clear. Means this is getting first reduced HNH on both sides, and then afterwards we are getting OH H and OHH on both sides. Hence this is very easy to understand. Then we have something like Dhawal H mechanism. So using Dhawal H also we got the aldehyde. So let's suppose I am using Dhawal H in this case, okay, or on this case, or maybe RCOCl acid halide. What will happen in all the cases is when we are reacting all this with Dhawal H, okay, which is nothing but or you can have something like this reagent as well, or rather can have directly a methyl group attached to Al. Okay, so now what will happen is the mechanism is pretty much simple. You have R C triple bond N. Okay, the lone pair of N would be actually attacking on the vacant orbital of aluminium. Okay, so we will get something like RC triple bond N plus and aluminium minus. Okay, next what will happen is aluminum also has a H here. I have already shown here. Yeah, also has a H here. So I'll show it here also. So this H goes and attaches itself to the C plus, getting CH, and we'll get the bond. Electrons will be taken back by the N atom, and we'll get something like this compound. This on hydrolysis in acidic medium will get RCHO. Okay, so this is the mechanism behind Dhawal H. Okay, next let us discuss the Itard reaction mechanisms. Itard reaction. So what happens in Itard reaction is we had something like other pH CH3, and we passed it in CrO2 Cl2, and we get a complex intermediate which is of the form PHCH OCrOH Cl2 whole twice, and this in presence of water will give me something like this compound. Okay, the in-depth mechanism for this is out of syllabus. You can directly remember this, that this complex is formed as an intermediate which on reacting with water molecule forms the aldehyde or benzene carbaldehyde. We have something like a toluene again, and we are using CrO3 in presence of Ac2O. Again we will have a complex intermediate of the form of this, and again in passing water over the intermediate we will get something like a aldehyde. Okay, we also have a side chain mechanism, okay, or the commercial usage or the commercial production of aldehyde, in which we use 2 moles of Cl2 and we pass H nu. So we'll get something like ClCl here, and this on having contact with the basic medium will get something like CHO. Okay, and then finally we have Gatterman-Koch reaction. Okay, so in Gatterman-Koch reaction again we have a benzene ring. We are passing CO plus HCl, presence of AlCl3, we would be getting a aldehyde. The in-depth mechanism is not in course or out of scope for the present J level syllabus, but we can directly remember that this is the reaction which takes place and forms aldehyde in the mixture. So we are done with this video lecture. From the next video lectures we'll be seeing Clemenson reduction. Okay, so till then, good luck and goodbye.